so here we've been asked to solve the following simultaneous equations using matrices and interpret the solution geometrically. Provide a sketch. Now the important part of this is using matrices. So we're going to need to use matrix methods to get to a point where we can decide what sort of solution we're going to get. So whether we're going to get a solution or no solution. And then once we've done that, we can use what we already know to sketch a straight line. You need to remember that in order to get a unique solution to an equation, your determinant is not equal to 0. A unique solution would imply that the two lines would cross each other at a point. If your determinant is equal to 0, you have one of two outcomes. Either there is no solution, so that would mean that we've got two parallel lines, or there are infinitely many solutions, so your two lines overlap each other. All right, so we've had a lot of practice with setting up matrix equations. So let's use matrices to solve these two. So we have 3x minus 2y equals 6, and we have negative 6x plus 4y is negative 10. That's equation 1 and equation 2. And we're going to let xy equal our x. And we're going to let our matrix A be 3, negative 2, negative 6, and 4. And we're going to let our matrix B be 6 and negative 10. Now we're going to show our matrix algebra. So AX equals B. A inverse AX is A inverse B. IX is A inverse B, and X is A inverse B. We always show that. Now, in order to find the inverse of A, remember the inverse of A is 1 over the determinant of A multiplied by D, negative B, negative C, A. And from here, we can actually work out what's happening with our determinant. So let's have a look. Our determinant of A is going to be AD minus BC, and that's going to be 12 minus, and negative 2 times negative 6 is 12. So our determinant of A is 0, and we need to draw a conclusion about that. So we're going to say, therefore, the matrix is singular. And there are either infinitely many solutions or no solutions. All right, so let's have a look at what's going to happen here. We've got 3x minus 2y equals 6, and we've got negative 6x plus 4y equals negative 10. Let's rearrange this into the gradient intercept form of a straight line. So if we have 3x minus 2y equals 6, I have negative 2y is negative 3x plus 6, and y will be 3 over 2x minus 3. And if we have a look at this one here, negative 6x plus 4y is negative 10. 4y will be 6x minus 10, and y will be 6 on 4x minus 10 on 4, and I can simplify that to 3 on 2x minus 2.5. Now what I want you to notice here is that these two lines both have the same gradient, different y-intercepts, so therefore they are parallel lines, and that means I've got no solution. They're two different lines. Okay, to sketch those, well, if I've got a y-intercept of -3 and a gradient of 3 on 2, 1, 2, 3, 1, 2, there's my other point, and there's my first line. So this one is my 3x minus 2y equals 6, and that one is at -2.5, 1, 2, 3, 1, 2. There's my second line. Hopefully I can get it to go through. No, I can't. Sometimes Apple jumps for me. That's not too bad. And there's my second line there, and that one was -6x plus 4y equals -10.